Sorry. Kedarnath, how are you?
Yeah, yes, sir. All fine.
Okay. Did you hear the? Did you listen to the video?
Yes, sir. I finished like 2 or 10 minutes of video. There's 40 minutes of video left of that example, which
Okay.
I couldn't finish
Okay.
by this time.
So you are able to make sense and appreciate, understand all those things, right?
Yes, sir. Yeah.
Very good. Thank you. So I shared two data sets. One is the places almanac, which ranks 329 places in USA with 9 variables, and other longitude, latitude, all those population variables. Okay, we only take those 9 variables and then try to see. There are 9. They are evaluating on 9. Is it possible that there are actually only 2 or 3 or 4 maximum, or something like that? Okay, 3. 2 is great. 3 is ideal. Okay, or 3 is ideal and 2 is ideal and 3 is great. So we looked into that one, and then I also looked into what is called the crimes. US arrest. Okay, that's what this data set is. Are you able to see my screen or screen?
Sir.
Yes, sir.
Okay.
We are able to see, sir.
This is the data. There are 4 columns of data: murder, assault, urban population, and rape. Okay. Sorry about this very gruesome looking data set. I don't know. This is the most often talked about. Very simple data set, so I use it also. But the point is, here there are 4-dimension data. These are all observations. Rows are observations, columns are variables. Okay, 4-variable data, 4-dimension data. Rows are not considered as dimension. Okay, remember that. No, variables are considered dimensions. And is it possible to reduce this, into a smaller dimension? That's what we did. And the mathematics tells us basically you find the eigenvalues, and eigenvectors, and then we call it they are the principal components. And so here is the simple command. What we do is this, basically PR comp is the it's part of the regular package. Okay, I think stat package. You don't have to. I don't think I loaded PR comp. Okay. Just to say, I don't think anything about PR comp is there. Okay, so it's not. So it's part of the standard package, so I don't have to load anything. I just call PR comp USARS datasets scale dot equal to true. That means I know I scale the data. In the previous one, I did not scale it. I did the log 10. You can do all these things, but scaling is pretty straightforward. First priority is scale. Okay, because basically you are removing the center and making everything to be recalculated. Value will have center of 0 value, and then standard deviation will be 1, because you're also dividing all the observation by their each of the variable by their standard deviation. So it's a scaled data set. Okay, so I do the PR comp, I got it, and then SDF tells me this is a standard deviation. And this tells me, in terms of ranking order, it tells you the importance of the particular dimension in the new space, in the new rotated space. This is the length of the vector, unit vector. Okay, in a sense, it's a unit vector. It's not really 1 unit. It's you got to say 1.5748 times. You got to use in the primary first principal component. On the other hand, this is 0.99. That's the length, again, the length of the primary axis. Suppose you are looking at it like kind of is it a ellipsoid? Yeah, ellipsoid, right? In the ellipsoid, you have in the one side is big direction, right? The big length, and the other one is smaller length. That's what an ellipsoid, right? And that's how it is happening. If it is only 2-dimension, this is the big side axis. This is the next smaller side axis. In a 3-dimension, this is the third side axis length that we are saying you need to weigh in to calculate the to calculate the original data. Okay, original data in this case, original data is the variance covariance matrix. Remember that we use the data to convert the to create the variance covariance matrix, and what we are modeling is really we are modeling the variance covariance matrix. Everybody gets it? We are modeling the variance covariance matrix. Everybody gets that idea? Why is that, variance covariance matrix we are modeling? Because we want to know how the spread, what is causing the spread? What is causing the variation? What is causing the spread? Everybody understood what I said?
Yes, sir.
Okay. So we are modeling variance covariance matrix here. Let me go back to the presentation. You're all listening to me, right?
Yes, sir.
Everybody?
Yes. Yes, sir.
Yes, sir.
Okay, all right. Once in a while I'll look into your video. Please show your video face. I don't mind if it kind of disturbs a little bit of broadband. Are you with me?
Yes, sir.
Paula? Durga?
Yes,
Okay.
sir.
Yes, sir. Let me try to share my
Happy?
Yes, sir.
Show up your face. It's very important. Okay. A little bit. Yeah. Thank you. So once in a while, I just want to take a look at you because I don't know whether you are there. What are you doing? All right. So let me go back again. This one, right? I'm talking about So let me explain all these things now one more time, right? So we got the standard deviation, which means it tells you the variance covariance, which means the dispersion of the whole data set. Which direction is maximum dispersion happens? This is the direction. First direction. This has this amount of variation in that direction. Is everybody gets that? We are modeling dispersion. Okay, we are modeling dispersion because we want to know what defines the spread, what defines what axis, what angles, what directions, what transformations explains the spread. And likewise, this is the least direction. Okay, least direction. Now, does this mean this direction is rate? Sorry, I don't want to use this word, but does this mean this is the population direction? Can somebody answer that question? We started with 4 directions, 4 initially, right? Murder, assault, urban population, rape. Does this mean that this is urban population? If not, you have to explain why. If yes, you say yes.
No, sir. Because it's in ascending. Because it's in descending order, but not in appropriate order.
That is Kedarnath's answer, right?
Yeah.
Okay, it's a descending order, but not necessarily in an appropriate order. So it is not. Does that mean? Let's say it is. Okay. So what you're saying is one of this is representing urban population.
Yeah. Yeah.
Okay. That is Kedarnath's answer.
There is a chance that 0.597 is representing urban population.
Here's a chance. Okay, that's what he says. Anybody else has any other answer? It's a very important question because it goes back and kind of validates your understanding. Anybody? Bala, Aruna, Satya, Durga, Abhi. Anybody wants to say answer? My question is, we have got 4 variables here. We got 4 variables here. Does that mean that 0.59 is representing urban population, or as he put, Kedarnath puts, there is a chance it represents urban population, but it may be some other number also. Any answer? A very, very important question I asked.
The primary dimension is a combination of all the 4, based on which the weightages are given in the previous eigenvalue output, that covariance matrix. So that would be my answer. So the second one will be the axis that is perpendicular to the primary dimension. So that would be my answer as of now. That's what I have understood.
Okay, so far so good. So what does urban population mean here? That 0.599 means what? So what you are saying is that, let me interpret. I think, you said it very close correctly. Kedarnath, please hear it out, because you committed an answer. I like that because nobody else committed. I like you committed, you answered it, whatever you thought is the right thing. Other people did not commit it. So you got to start. Okay. Now, he says, Bala said, no, it's each one of them is a linear combination of other directions. Okay. In other words, the first one refers to linear combination of all the 4 variables. Second one also refers to the linear combination of all those 4 variables. but it is the direction which has the next next total amount of next amount of variance that is explained. If everybody gets it, that's what Bala says. Perfect, Bala. You know what you said is right. So 0.59 doesn't mean any one of them. It means it's a third best linear combination based direction. That means basically you are rotating the data set. You are rotating the data set and finding the first maximum variance explaining direction. Next is perpendicular to that. You find the next variance explaining direction, but it won't explain that much variance compared to the first one. Okay. Third one is 0.159 refers to third dimensional perpendicular to this plane. The first axis, second axis defines a plane, right? It's a kind of plane. It's called plane. It's XY is a plane. XY, if you use 2 dimension, it's called a plane. So third dimension, the 0.59 refers to a third dimension perpendicular to that, but its explanatory power is less than the previous one, which explains less than the first one. Everybody gets it?
Yes, sir.
Excellent, excellent. Thank you very much, Kadarnath. You know, you also said yes, sir. That's great. You have to answer, you know, Abhi and Durga, you have to commit, you know, understand, say, even if it's wrong, it's okay, because only if you say something, which means you are committing it, you will be able to correct it. Okay? Everybody gets it? Satya Karchungla? Okay. How about Aruna?
Fourth plane, sir.
Durga?
So எல்லாமே வந்து நீங்க perpendicular to each other சொல்றீங்க.
Yes.
So first இது x, second இது y, அடுத்து z அப்படி வச்சுக்கலாமா?
We don't want to say x, y, z. Well, you can keep it, but that x, y, z are nothing to do. I mean, not the same as the initial variables. It's a linear combination of those variables. So don't call it as x. You call it as the new direction, principal component, first principal component, second principal component, third one. You call it that way.
Okay, sir. இப்போ அதோட டைரக்ஷன் எனக்கு அப்ராக்ஸிமேட்டா நீங்க டிரா பண்ணி காமிச்சா கொஞ்சம் புரியும்னு நினைக்கிறேன்.
Okay. Well, let's see. You know, I will try to show something here. You will see it. You know, I showed one example last time. You will see it.
202 அப்படின்னு ஒரு எக்ஸாம்பிள் காட்டுனீங்க சார், அதுவா சார்?
இல்லப்பா, 202 just tells you it is mapping it. 3-dimensional point is mapped into 2-dimensional plane. Okay. Okay, one moment. I wanted to go back to the example. Here it is, Satya. Okay, I'll make it bigger so it is easier to see. Do you see this one? This is the data clumping. The way the data happened like this in a 3-dimensional space. Do you see this? This is Z. This is X. This is Y. Satya, are you following? But the data is clumped in this way. I'm saying this is the maximum variance carrying angle direction that centers through this data. This is the axis. This is your first transformed, rotated axis. That you call it the first principal component. Everybody gets it?
Yes, sir.
There are 2 other colors. Do you also see that one? Pink and orange or yellow. Get it? Pink is perpendicular to this axis. This orange is also perpendicular to this axis, but let's consider this one. Pink is the next best direction, okay? Next best, which has the next best variance explained. Is everybody with me?
Yes, sir.
Yeah. Correct?
Yeah, okay, sir.
Now this and this together defines like something like a XY plane. No Z axis. Am I right? This axis and this axis together defines something like a XY plane here. But it's not XY plane. It is it defines a plane on its own, right? Together, this is the maximum, first maximal principal component, second maximal principal component. Now, perpendicular to this plane is it has to be only this and this direction, right? I mean, or this direction, either way. But this is the axis that cuts through this point. Is everybody agrees with me?
Yes, sir. And can you relate this numbers 1.57 and 0.99 into this graph, sir? For example,
Yes,
this 1.57.
This point, this is what 1.57 refers to. Thank you very much.
And that 1.57 is containing some amount of that murder, that is minus 0.5 of murder and minus 0.47 of assault or something like that into this direction, is it?
No, the 1.57 refers to the length of this direction. That's all, length.
Okay.
1.57 refers to the length of this direction. The next length is, what is it, 0.99? That refers to this length. In other words, the data are mostly distributed in this angle, and I can use the measurement that is derived out of mathematics is at 0.99. On the other hand, this is 0.57 or 0.59 or something like that. Okay, this one.
Yeah,
Are you
we got some minus 0.5 or something into that. I think
that was the
previous...
weighting process. No, right now I'm talking about how much variance is explained. You are talking about weighting process of, you are weighting these original axes in such a way that how you can translate, you are weighting the original axis so that you are defining new directions that centered at this point here, which is the x bar, x1 bar, x2 bar, x3 bar, all those things, or x bar, y bar, z bar.
Okay.
We'll come to that. He kind of, everybody did get to his point of view that he kind of went to know how is it related to the points that data points that we'll talk about. So here is I think this is what you are talking about. Am I right?
Exactly.
So it's where we are coming there.
Okay.
Is everybody clear on what I am talking with him? Is everybody clear?
Sir.
Yes, sir.
Excellent. Very good.
Sir, one question. Hello, sir.
So
1.57 you said times 1.5 times.
So if you use the axis, see x1 in the original space, we are talking about the original space of data, right? What is your dimension? 1 0 0 0. 4 dimensional 1 0 0 0. Next to axis is 0 1 0 0. Third axis is 0 0 0 1. I mean 0 0 1 0. Fourth axis is 0 0 0 1. Right?
Correct.
There you are weighing in for every point. What do you do for x1, x2, x3, x4? Now ஒரு point இருக்கு. நீ என்ன பண்றீங்க? x1 times that unit vector 1 0 0 0, right? x1 times e1
right.
plus x2 times e2 plus x3 times e3 plus x4 times e4. That is same as that, right? The vector x1, x2, x3, x4 is that.
Right.
Everybody can say?
Yes, sir.
Okay. So what we also are going to say is that now it is the same point is written as now the new vector. Whatever the vector original points is, right? Original point. We are going to come back to the original, how to calculate the original points. Okay, if you want it, but really, going forward is what matters. Going backward is not important. It is only to convince ourselves the relationships. Going forward, no. So reduce this dimension into a smaller number of dimensions so that you can express all the variance and all the observations in the new dimensional data. Correct. That is what your principal components are.
Agreed.
Okay?
Agreed.
So what we are saying is that the principal component, instead of E1, E2, E3, E4, you are going to write it as PC1, PC2, PC3, PC4. So original point, the point, new points. In the new points, you are going to get new points also, right? In the new axis, you are going to new points. New points times PC1 plus new points times PC2. I'm talking the first dimension new point times PC1. Second dimension new point times PC2. And the knowledge is somewhat panamana, you get the current representation. Now, how do we go back to the original data? I will come back to that.
Okay.
So what I am saying is, these are all connected in the sense that it's a linear combination. By that we mean we are basically rotating the data so that we can understand and focus on the important dimensions. Rotate, translate. All the eigenvalues, eigensystems are basically doing rotation and translation into a new place, new center, and new data space. Okay. Now let's go back to the example. We'll have to go back to that. Your question also.
Sir?
Yeah.
by times PC1. What is PC1 value over here? The standard deviation, is it the PC1 value?
Standard deviation. No, I'm looking at this screen. Can you talk about it using this example? So look at the screen.
Yeah, yes, sir.
Which one you're talking here?
Like when you said times PC1, like 0.535 times PC1.
So this is a PC1. This is the PC1. This is the whole vector. This is the weighting. Each principal component is a weighting process. We are creating a new weight. What is the purpose of the new weight? I'm basically saying with that new weights, you are not only centering it because you already scaled the data, not only centering it to the x bar, y bar, x1 bar, x2 bar, x3 bar, x4 bar, the 4-variable, 4-dimensional data, but also standardize the data and rotate the data.
Okay.
Right? In such a way, what is the purpose of the rotation? The rotation is that the first axis is identified as the maximum variance explaining axis. Second axis is perpendicular to that, and it explains the next maximum variance in the data. And the third one is next third maximum variance, and so on.
Okay.
Okay. Now, so this is the principal components. These are called principal components. And using the principal components, I can see in the original data. Let's say you have this one, right? For example, yeah, I'm only talking about centered data. Okay, this is the PC3. I don't want PC3 because that is untranslated. I'm going to use the PC1. Here it is, PC1. Okay. Original data, translated data of PC1 is, I have to do this. I'm looking for the translated data. Okay, this is the original data. Okay, so let's do the translation. It's hidden there, but I'm going to create it, right? Okay. So what am I getting here? So this data is how many rows are there? It's 50 states. Okay. It's the number of states are 50, and then the columns of variables are 4. So these are the dimensions, and these are the observations, right? So standardized data means we get 1.24 here, right? Alabama model. But original data is not that one. Its original data is something else. What is I don't know. Remember this one. Here it is. Original data is 13.2. Are you with me? Right. I scale the data, and that's what is used to calculate our principal components. Okay, because we don't want to use unscaled data because different units can create different problems. In this case, that's not an issue here. But suppose this is age and this is income. Income is a lot more variation unnecessarily. We'll be explaining the variation, thinking that it's important variable. It may not be. So, this 1.24 is the scaled version of the So you are taking the murder minus average of the murder divided by the standard deviation of the murder for this Alabama state. That's what this value is. Okay. Now, what we are saying is that that's a scaled data. Now, these are the axes, rotation. It's a good word. I like this actually. PCA1 is the one that I'm talking about. PCA1 is the one. PR comp. Package used is PR comp. Okay. Package used is PR comp. And rotation refers to this is the first axis. Reweighted axis are this. Second axis, best axis is this. Third best axis is this. Fourth best axis is this. Now, so these weights are created out of the scale data because I had scale dot is equal to true, right? In the PR comp when I was calling in. In this particular example, when I called in, I used PR comp is equal to scale.
Scale dot is equal to true.
True. Scale dot is equal to true. Correct. Good. Thank you. I was trying to go back and show that. So, so we got the what weights to do, what weights to give for each of these dimension in the new rotated space. What weights to give for the PC1, for the PC2 direction, and PC3 direction, PC4 direction. So the question you have, I think you raised that yesterday. I know I have two things to answer today before I go to more other things. You asked the question, how can I go back? So here is the reference I want to go through. How can I go back to the original data? Can I go back to the original data? That was the question, right, Bala?
Yes, sir.
Okay. So how to get back original data point from PCA? If you want to get back to the original data points, everybody listen to me. You have to use all the 4 principal components. Do you agree or not?
Right.
But
Yeah.
our purpose was to reduce the dimensions. So we got excited with, 2 dimensions is good enough. Right? But the thing is, if I go and chop off those remaining 2 dimensions and use only 2 dimensions, what happens? I can't use only those 2 dimensions to go back to my original data. I have to use all the 4 dimensions. Everybody gets that point? Yes.
Yeah, I might get closer to my original point, only probably 80% or 82%.
Right.
Whatever the loss of data will be there.
Yes, exactly. Satya, correct? Excellent. இல்ல இப்போ என்ன question கேட்டாரு, original data I am expressing it. I haven't given you the mathematics of it. A lot of little details are there. Okay, so I'm going to give you that too. Let me explain this way. I think he got the point, but I'm going to go back to that mathematical expression. Then you will be able to appreciate. Okay, I didn't go there because I expressed there a lot of things. I don't want. This is really. This is what I wanted. Don't worry about the below one. Everybody, look at this one. Sigma is equal to. Do you see this one? Everybody?
Yes, sir.
Correctங்களா?
Yes, sir.
சத்யா, இந்த ரொம்ப பார்த்தா ரொம்ப அக்லியா இருக்கும், அதெல்லாம் ஒரி பண்ணிக்காதீங்க. ஈன்னு வச்சுங்க இதெல்லாம். This is a mathematical language, but ஈன்னு வச்சுக்கோங்க. Okay, X E1 E2 E1 transpose E2 transpose. So what we are saying is that, everybody listen very carefully. This is the variance covariance matrix. This variance covariance matrix is written as a sum of disjoint sum, right? As a disjoint sum of P components, because the variance covariance matrix is P by P. That is P-dimensional variance covariance matrix. Everybody understands what I'm saying? Just understand. Okay? So what we have so far said is this is the lambda is the first eigenvalue, this is the first eigenvector. But this is a vector. That means this is perpendicular like this, right? Vector. This is like a vector. So, but if this is E1 times E1 transpose, this is what it means. It's a matrix. Everybody agrees?
Yes, sir.
Excellent. Everybody gets it?
Yes, sir. இதுல இந்த லாம்டாங்கிறது வந்து eigenvalue vector பின்னாடி சொல்லுவீங்களா சார்?
Eigenvalue. Lambda is the eigenvalue. E1 is the eigenvector. First eigenvector.
Okay.
Okay. There is a statistical interpretation of it, statistical talk of it, application of it, and then there is a mathematical foundations of it, right? I'm going back to basically what I'm saying is that this is one lab. If I can factor this into various new dimensions and using lambda, the eigenvectors and eigenvalues. Eigenvectors and eigenvalues, right? Which you understood yesterday. Then it is really sigma can be fully rewritten. If I use all the eigenvectors and eigenvalues, it will come to exactly.
Okay.
But I know the bottom, first ones are most important, last ones are least important. So if let's say the bottom, the 3 length, only 2 use பண்ணனா, it won't be exactly the same. It will be closer. But it's not exactly the same. Everybody gets that?
Yes, sir.
Excellent. Excellent. Aruna?
Yes, sir.
Okay. Kedarnath, Abhi and Durga.
Yes, sir. Yes, sir. இதுல first one last one remove பண்ணிட்டா it's giving some
first one is the maximum.
remove பண்றதுனால என்ன யூஸ்?
First one is the maximum explaining dimension, right? First one is the maximum explaining dimension. Next one is next best explaining variance explaining dimension. You remember variance explanation is fundamental for us, right?
Okay.
Fundamental for regression model, it's variance. You are explaining the variance. Everybody gets that. Regression model is explaining variance. Everybody gets that.
Yes, sir.
Yes.
I'm going to worry about dimension. I don't know whether you understand that part. But that's because you are using on the left hand side only one variable. But here it's a blob of dimensions. Correct? Right? It's a lot of dimensions. So we are trying to resolve into a translated world, rotated, translated means move basically. Transform both move and transform na you can say translated means you're moving it. That means centered, right? X bar. And then rotation. All those things are mathematically in one shot achieved by this decomposition formula. This is called spectral decomposition. So variance covariance matrix is rewritten as a sum of lambda 1 times its eigenvector times its transpose plus lambda 2 times its eigenvector times transpose of its eigenvector, like that. By doing this, you are basically getting a matrix because இதெல்லாம் நீங்க பண்ணீங்கன்னா கடைசில மேட்ரிக்ஸ் வரணும். இது வெறும் வெக்டர் இருந்தா என்ன வருமா அதுல ஈக்குவல் பண்ண முடியாது. Okay, it has to be and it comes out to be a matrix here. If this is a 2 by 2 matrix, this is how it will keep on adding. Okay, what I am saying is the mathematics gives us the assurance that these are all ranked in order. This is the least explaining variance explaining dimension. This is the maximum variance explaining dimension. So if you drop all these things in the bottom ones, let's say bottom 2 or 3, it's not going to be exactly same as sigma. It's going to be closer to sigma.
Closer to sigma, right?
That's what your question was. Yes, the answer is, and I explained it using this symbol. Satya, உங்களுக்கு புரிஞ்சிருக்கும்னு நினைக்கிறேன் இப்போ. கரெக்ட்டா? Durga?
Yes, sir. Purinjadu, sir.
Excellent.
And the lambda என்ன சார் வேல்யூ E1 eigenvalue E1t வந்து அந்த prime eigenvalue ஓட transpose ஓகே lambda valuesல என்ன கொடுக்கிறோம்
lambda is it tells you the strength of the dimension.
Okay. That okay. In the case of the 1.57, 0.99.
Yes. It's yeah. Yes. Okay.
Thank you, sir.
Everybody is with me?
So then what about the S?
உங்களுக்கு புரியலன்னா அடாவடி தானே பண்ணணும். புரியணும் அப்ப எனக்கு புரியலையா என்ன இது சொல்லணும்.
Sir, what about the second equation?
Second, don't go. I said don't go there.
Okay. Sorry. Yeah.
It's very different. Do you see this one? It's very different. Yeah. Right? I'm sorry.
Is that continuous and discontinuous functions?
No. Don't go there. Yes, this is very powerful. It's very powerful. Because anyway you asked, I will tell you that. This is a square matrix. Do you see this one? This is a square matrix. Okay.
Yes.
But what if your data needs to be explained, which is not a square matrix? That's what this is. Okay. So, but the structure is same. This is called singular value decomposition. This is called eigenvalue decomposition. Okay. We're going to come to this one later. Okay.
Okay.
Yeah. Okay.
Okay. Cool. Very cool. Now, any other question pending here? Now I have to go back to. So what I was saying is now, if you know what your point is, can I get back to this data? Of course, if you know all these things, you can get back to this data.
Right.
But your data is not this. Further there, you are translating the data into scaled data, and then for the scaled data variance, you are modeling it like this. Think about everybody. He asked a good question. How do I go back? But going back is not straightforward. So we have to do some little bit more work. What is it? Because this decomposition is only for the variance covariance, but we really want the original data. Right? Everybody with me? Everybody with me?
Yes, sir.
Everybody with me? Everybody with me?
Yes, sir.
Yes, sir.
When you are in the class, please be fully attentive because we won't get this chance one more time. That's why I was kind of, Kedar, no, I wish you were there yesterday. So we had a good time. I suppose you all feel that way, We had a good time yesterday. So when you are here, please be fully attentive. I know world is, life is precious. You have a lot of things to take care and so on. All right. Now, so you understood what is meant by spectral decomposition? At least I use the word spectral decomposition.
Yes, sir.
So can you say it in English? I always ask this one. Say spectral decomposition in English. Everybody has to say. Is it a deal? Because it's such an important result. Everybody understand?
Yes, sir. No, sir. Spectral decomposition is வார்த்தை இப்பதான் first time use பண்ணீங்கன்னு நினைக்கிறேன்.
I already used it.
Okay.
Listen. You'll be here.
Okay.
Spectral decomposition is basically the sigma rewritten as sum.
அது யூஸ் பண்ணல சார், லாட்டன் பிரின்சிபல் தான் சார் யூஸ் பண்ணிருக்கீங்க.
No. இன்னைக்கு சொன்னேன் நான் ஸ்பெக்ட்ரல் டிகம்போசிஷன் சொன்னேன் நான் ஒரு 5 நிமிஷத்துக்கு முன்ன 10 நிமிஷத்துக்கு சொன்னேன் பட் I wanted to tell you that word also because that's so because it's a decomposition. That means composed into sum, right? Decomposition that you and the word first time I use பண்ண இன்னைக்கு தான் decomposition. அது சொன்ன உடனே I wanted to bring that word spectral decomposition because it's a critical word. Okay. This is what the spectral decomposition is. It is a summation of the decomposed dimensional contributions to the sigma. Everybody gets it?
Okay.
Okay, now my question is this. Say it in English.
Okay.
Who wants to jump in first? You have to say it in English. Otherwise, you will not remember this. You will never remember this. Even if you say it, you may not remember. That's a different thing. But if you don't say it, never. It won't get you into your system. What does this mean in summation? Okay, I'll say once, you got to repeat next time, okay? I'm saying the variance covariance matrix is இது சொன்னோன்னே இப்போ இந்த டைரக்ஷன் போனோடனே உங்களுக்கு ஒரு கொஸ்டின் வரும். என்ன சார் இது பிசிஆர் தான் பேசிட்டு இருக்கோம், இது ஏன் அங்க வந்தது? Anybody gets that question?
Yeah.
ஒருத்தருக்கு வந்திருக்கு. பாலாக்கு வந்தா? துர்கா?
இல்ல சார், இது இன்னும் ஸ்பெக்ட்ரல் டிகம்போசிஷன் அந்த ஃபார்முலால தான் சார் இருக்கேன் நான்.
Stuck there. Forget about spectral decomposition.
Okay.
Oh, gee, maybe I'm confusing you all. Okay, now, what did we do?
Yes, sir.
We wanted to explain this variance. That is all we are doing. Explain this variance in fewer dimensions if possible.
Yeah.
Explain this variance in fewer dimensions if possible. That's all we are trying to do. அதுக்கு என்ன சொன்னேன் நானு? So if I have a mechanism, mathematical mechanism that will, prioritize the directions and give me the ability to translate the data, explain all those data, then I will use that, and that is what is called the eigenvalue systems are eigenvalues and eigenvectors. When I say system, that means both eigenvalues and eigenvectors. Okay, eigenvalue systems are.
Yeah.
Okay. Everybody got it? Up to that, I have been saying I didn't say anything new so far.
Right.
And then I said the first eigenvalue by mathematical process, first eigenvalue eigenvectors explain the most single dimensional variation in sigma. I explained this before, right?
Right.
The second one is the next most single dimension explaining sigma. Together, first and second are the first maximal explaining two dimensions that explain sigma. All these things I have already explained, said many times. Okay? Yes. And it is in decreasing order, the least ones are at the bottom. So, spectral decomposition, same as eigenvalue decomposition. I said that too. Everybody gets it? Did you hear that? Eigenvalue decomposition. I said that too. Eigenvalue decomposition, spectral decomposition are both same. So eigenvalue decomposition, what it says is I am able to decompose the total variance here into dimensional variance. Each of the dimensions its own variance. Okay, that's what it is. It is a sum of the dimensional variance that explains the total variance. Sum of the individual dimensions variance that explains the total variance. The total variance is the sigma, which is the variance covariance matrix. Everybody got it so far?
Okay.
If I ask you to explain what is meant by eigenvalue decomposition, which is same as this, which is same as the principal component analysis, nothing new, but it's a different angle of expressing my points. Correct? Enna this Satya correctla? So நீங்க சொல்லுவீங்களா? If I ask you what is meant by eigenvalue decomposition, why is it needed? Will you explain that to me? Excellent. சொல்லுங்க பாருங்க. Just let's try. That's okay.
So first value வந்து பாத்தீங்கன்னா sigma 1 sorry lambda 1 the eigenvalue of the lambda 1 plus the eigenvector eigenvalue transpose னு சொல்லி பக்கத்துல உள்ளது.
Right. சொல்லுங்க.
So இது வந்துட்டு so இந்த வேல்யூ என்ன பண்ணுது அப்படினா expects the maximum variation in the data first இருக்கிற வேல்யூ
in the maximum variance in the multi-dimensional data. Yes.
So அடுத்து உள்ளது பாத்தீங்கன்னா அடுத்து so bottom last உள்ளது பாத்தீங்கன்னா very
least variance in the data. Okay, இது ஆர்டர் பண்ணி கொடுக்குது மேத்தமேட்டிக்ஸ் கூட. அது எப்படி பண்றதுன்னா மேத்தமேட்டிஷியன்ஸ் ஏதோ பண்ணி ஏதோ ஒரு அல்காரிதம் டெவலப் பண்ணி நம்ம கொடுத்துனாங்க, நம்ம யூஸ் பண்ணிக்கிறோம். That's all to it. So the total variance is a sum of the new independent dimensions, because each one is perpendicular. They are called independent, right? Each one is a perpendicular dimension. The lambda 1 epsilon 1 defines one dimension, one particular angle direction. The epsilon 2 defines perpendicular to that direction.
Correct.
And lambda 3 yet perpendicular to those two. Lambda 4 yet perpendicular to those three.
But that doesn't be, yeah, but we will not be able to represent it in figuratively if it crosses 3, yeah, sir.
It's or interpretability adod nirthikrom nam. Yeah, but if somebody says that first 3 dimensions are something, there are problems where from 3 dimensional only 30% will explain, or 20% it will explain, 30% will explain. Let's be more generous, 30% it will explain. Okay, out of 10 variables. That's not a good one, right?
Right.
But because the variance is too much. But most of the problems are not like that. See, this is the statistician world.
That
I will always say most of the problems are not like that. This is how statisticians survive.
Okay.
Right? Correct, Satya? Good. Excellent. So, Durga, you solla mudiyadha? What? Say it in English. This one. Durga or Abhi, one of you.
Yes, sir. English, yes, sir. Sir, I will try, sir, but
தமிழ்ல சொன்னா கூட பரவாயில்ல. I will buy it.
இந்த ஈக்குவேஷன் அதாவது லாம்டா ஐகன் வேல்யூ எப்சிலான் 1 அதோட டிரான்ஸ்போஸ் வந்து மேக்ஸிமம் வேல்யூ இது ஃபர்ஸ்ட் ரெண்டும் வந்து இந்த க்ளோசர் டு எப்சிலான்னு சொல்றாங்க. லீஸ்ட் வேல்யூவை வந்து ரிமூவ் பண்ணிடுறாங்க, ஏன் சம்திங் இட்ஸ் லோ வேல்யூ. நெக்ஸ்ட் வந்து இதுல என்ன சொல்றீங்கன்னா இதோட நேம் வந்து ஐகன் வேல்யூ டீகம்போசிஷன். Next, the sum of all individual variance divided by sum of all independent variables.
நிறைய சொல்றீங்க, நிறைய எல்லாம் வேண்டாம், எனக்கு இதை மட்டும் சொல்றோம். என்ன மீன் பண்ண என்ன, what is this equation say in English? நீங்க நிறைய மத்ததெல்லாம் எடுத்துன்னு வரீங்க நீங்க. ஓகே, எப்படி ரேங்க் பண்றதெல்லாம் வருது, என்ன வேரியன்ட், how much variance,
highest values மட்டும்
சொல்லுங்க. Is it a break time? Sorry. What's the time now?
It's 5:30 only, sir.
Yeah,
5:30 only, sir. No, half an hour pola, sir.
Half an hour pola. Okay.
5:30.
Okay, so listen to others. Durga Abhiya பேசினது.
Abhi sir.
Okay.
Abhi sir.
So listen to one more time. Let's say, Bala, can you say this in English? This is a very, very fundamental important result. Because in the basement in Narayana, later on, singular value decomposition, you also get factor analysis. So can you say this in English? This is the equation. Yeah. Don't worry about spectral decomposition, eigenvalue decomposition. It's simple. Forget about all the other words. Just say this.
We are trying to explain the variance covariance matrix using the new dimensions. அதில் இருக்கக்கூடிய weightages பொறுத்து lambda1 அப்படிங்கிறதுக்கும் அதோட corresponding அந்த maximum variance இருக்கக்கூடிய அதுக்கும் அதோட corresponding eigenvalue and eigenvalue transpose multiply பண்றோம். இதே மாதிரி eigenvector செகண்ட் இதுக்கும் அதே மாதிரி அந்த செகண்ட் பாராமீட்டரோட அந்த நியூ டைமென்ஷனல் லென்த்தும் இது அதுக்கு கரஸ்பாண்டிங் eigenvector அதோட டிரான்ஸ்போசிங் எடுத்து இந்த மாதிரி ஒரு 3 dimensions எடுத்துக்கோனா அது மாத்திரம் பண்றோம். பட் if we have to get back to the exact same point from the original starting point, we have to include all the dimensions. Only then we will be able to go back. In case if we are dropping any, we will not be able to go back to the exact point. We will be closer to it.
Right. But again, if I use this, I will only go back to this. But the original data points are different. The data points gives you this, and from there you get this. If you want to go to the original data points, you have to go from here. Already you are chopping off something here. So from here you have to go back to this. From here you have to go back to this and use the mean to go back to the original data. Are you with me? See, the original data has the original data are x's, right? X variable, x1, x2, x3
right, sir.
அந்த வேரியபிள் இருந்து நீங்க the standard variance covariance matrix uses the data and the means as well as individual standard deviations to get this. Correct. All those things you have to reverse back to get the original data point because you asked that question.
Correct.
Last time. So I want you to be careful that I will explain something which will get you that, but these are all the things you are factoring into that, why you are doing it in a particular way. Are you guys able to hear me well? Huh?
I can hear you.
I'm able to.
Okay. I just want to make sure because I think IOA has some problems. Sorry about that. I don't know what to do. The funny thing is. I see. Okay. I'm wondering whether you can fix something on the duplex or not, right? So in the laptop, then it will not try to. It will only try to receive. It won't try to respond. So when it tries to respond, it mixes up, some channels get mixed up. Unfortunately, at least 1 or 2 cases are here that they are able to hear, and it's it bothers me that IOAS. Who is there? Sindhu da irukanga, vera yarum illaya?
Venkat is not there.
Oh, Venkat. Venki is not here. Okay. Fine. Hopefully the recording is okay. Good. Let's see. So, okay, let's finish this. There's a lot of material still pending to be done. Okay, so far so good, everybody.
Yes, sir.
Okay. What I wanted to show you is 1 second. Let's go back to this one. I want to finish yours, and then I want to finish what Aruna asked yesterday. Okay, yours is. Can we go back to the data? I'm still, I wanted to finish that one. Bala, are you ready? So,
yes, sir.
So let's say the original data is X. I'm going to explain this. This is done well here, okay? X raw, that is the raw data, which is a N, in this case, 50 states and then 4 columns, right? The original data. 50 states, 4 columns about crime data. Okay?
Yes, sir. Yes.
Okay. Now, after we scaled it, right? So we subtract X minus mu divided by the, for each of the variables, X minus mean, its mean, the column X1 minus X1 bar divided by standard deviation of X1 bar. Okay, that is the centered matrix, data matrix. Let's call this is the raw data. This is the centered. Everybody hear this, because I'm spending time and I want to answer. Bala asked a good question, and answer is to everybody. So this is the raw data. This is the centered data. So far so good.
Yes, sir.
Yes, sir.
Now let V be the sigma. Whatever we talked about is V here. Okay, sigma whatever I mentioned there is here V. Is the P by K matrix. It's not 4 by 4. It's 4 by 2, for example. Are you with me? For example, because I'm using only 2 eigenvectors and its corresponding eigenvalues. So far so good?
Yes, sir.
Because we believe that 2 is enough. Okay, and 2 represents the largest 2 eigenvalues. Then the original data, n by k. The original data is what? N by n rows and p columns, right? But then the n by k matrix of PCA projection. So these are the, given the PCA, we are projecting that data, and that is Z. We take the data, X data, that is centered data. We use this transformation that we derived out of the eigenvalues, eigenvectors, first 2 eigenvalues to eigenvectors. And then when I do this transformation mathematically, it comes back to this one. This is approximately closer to the original data. Right. If I take care of something, and I'm going to tell you what I take care of something means, because I have to subtract the mean, de-standardize the data. That's what I'm telling you. Okay. This is just, you just add to the centered data. It's, I'm getting that using only two-dimensional data, 2 eigenvector values. So here is an example, graphically it shows. This is the original data, okay? And this is the direction. And then there is also another direction here. And then the center is here, okay? It's not, center is not here, center is here. Okay, so this is 0. So this is your centrally original data. So first PC refers to this direction, okay? And the reconstruction so far with unstandardized data gives you this. Unstandardized data gives you this. I basically, kind of some kind of rotation. Okay. So PCA reconstruction should mean PCA scores times eigenvectors transpose. Eigenvectors, here talking about eigenvectors refers to the V here. Plus mean. If you do all these things, then you will get back to the original data. But still, it will not be the exact data, because you got to, unless you use this all the eigenvectors, which means V should be close, V should be sigma. Yeah, which means all the eigenvectors are used. Okay, so this is to get back to your original data. But right now it is only called PCA reconstruction. I didn't say original data reconstruction, because I'm using part of the dimensions only.
Agree, sir.
This is how you can get back. I answered your question. I want to go back to this is, I don't expect that this you understood immediately, you buy into it and so on. You have to think about it, you have to do some little bit of exercises and so on. Exercise your brain, you will find, you'll be able to explain this to others also. So far so good, everybody? Kuncham harder question, I answered, because there's a lot of work involved there. We can go back, we can do it as an assignment maybe if you want. But that's not the main assignment I want to really solve. I have other things to do. Okay, that is to solve the problems, explain the dimensions, and then explain the graphs. And that's what I want to go back. Okay, from last class, that's one of them pending.
Thank you, sir. Thank you.
Okay, welcome. So I want to go back to this R. You remember we did the plot. Up to that we came last time, isn't it? Everybody? So in this one, I want you to better understand, take the extremes, then it's easy to compare, okay? This is Florida here, this is New Hampshire, Iowa here, okay? New Hampshire, Iowa, Florida. In this case, New Jersey, and then Arkansas. So if you do this comparison, it will be easier on you. Everybody understands that? Of course, you will be able to go mentally, you can figure out certain things as you go this way, here, partially here, partially here, partially here. All those things you will be able to say, okay? And then you will give up after a while saying that, no, okay, I can't distinguish this versus this as much as I can distinguish this versus this. Are you with me?
Yes, sir.
California versus Vermont, California versus West Virginia is a lot more easily, convincingly explainable compared to Missouri and Wyoming. That's clear, right? That statement is clear. Okay?
Okay.
Yeah. Are you with me, everybody? I have to see your face. Are you with me, everybody? Satya, correct?
Yes, sir.
கேக்குது சார் பட் இந்த இன்டர்பிரேஷன் எனக்கு புரியல அது.
இதான் இப்போ போறோம், இன்னும் பண்ணல, நம்ம பண்ண போறோம். We are going to go through this. Okay?
Yes, sir.
All right. All right. So now, what I am saying is that this is PC1. This is PC1. What is PC1? This means this axis, perpendicular axis, is PC1. This horizontal axis is PC2. Am I saying it right? No. No, I didn't say it correct. The horizontal axis is PC1, perpendicular axis is PC2. Why I corrected it? How could I say that? You could also say that correctly or not, okay? Because the range of values is going this direction, -1, 0, +1, 1, 2, and so on. That is PC2. So this is perpendicular axis is PC2, horizontal axis PC1. So far so good. Just let's take one step at a time. So far so good, everybody. Okay.
Sir, -1 -2 மாத்திரம் வச்சு சொல்றீங்கன்னா ரெண்டுத்துலயுமே அதே தானே சார் இருக்கு. இதுலயும் -1 -2 சார்.
என்ன சொல்றேன்னா where it ranges, okay? These are all the little bit of confusions, everybody has it. I fell into it also. First of all, you can also say first variable சொல்லும்போது எப்பவுமே நம்ம horizontal axis சொல்லுவோம். அப்படி நான் அது மட்டும் எடுத்துக்க விரும்பல. எதையும் சொல்றேன் நான். ஏன்னா variations are happening this way, okay? -2, the measurements are happening -2, -1.50, 0.5, 1.5, like this, right? So PC1 is varying this way. So
okay,
PC1 is good enough. One variable, that one dimension is good enough to explain Florida and New Hampshire. Do you agree with me? Because it is not going in this direction here or here or here or here. It is on the axis. Everybody?
Yes, sir. Data புரிஞ்சதுனால I am able to come back. இந்த இடத்துல கரெக்ட் பண்ண முடியுது எனக்கு.
எது டேட்டா புரிஞ்சதுனால?
அதான் டேட்டா புளோரிடாவுக்கும் நியூ ஹாம்ஷயருக்கும் நடுவுல இருக்கிற டிஃபரன்ஸ். இங்க கிளைம் ரேட் வந்து புளோரிடால ரொம்ப அதிகம். அதனால இப்ப லெஃப்ட் நேத்து சொன்னீங்க சார்.
ஆல்ரெடி லெட் மீ கோ அண்ட் see. அது எனக்கு தெரியல.
நேத்து சொன்னீங்க சார். அது நியூ ஹாம்ஷயர்ல வந்து கம்மியா இருக்குன்னு நேத்து சொல்லிருந்தீங்க.
ஓகே. ஃப்ளோரிடாவுல பாருங்க, இங்க ஃப்ளோரிடாவுல 15.4 murder, assault is 335, rape is 31, urban population. It's an urban population. 80, rape is 31, and then murder is 15. இதுலயே பார்த்தாக்கா இது very close to the maximum, right? இந்த லிஸ்ட்ல இருக்கிறது இது probably 10, right? It's close to the maximum. Do you see this one? Because இங்க இருக்கிறதுலயே
ஜார்ஜியா அதிகம் நினைக்கிறேன் சார். ஜார்ஜியா ஏதோ 16,
15, 17 அவ்வளவுதான். அதான் மேக்ஸிமம் வேல்யூஸ். Georgia, Louisiana, Mississippi. Okay? Right. Now, in the case of, I'm not saying this, the Florida is here because it is Florida is maximum here. That's only part of the story, because you remember everything has to weigh in, right?
Right.
All these four have to weigh in to get the PC1. Okay, but in the standardized data, you still have, it is a negative value. Remember that. This is the question Aruna asked. Sir, negative positive negative confusing. Correct? She caught on that. Excellent. She caught on that one. Okay, it is confusing, right? Because here they are saying it's a maximum positive. Maximum is what? If I center the data, this should be positive number, but I'm seeing it as a negative number, right? It is just a matter of translation of the axis. Remember or not? Okay, I can put it. So it is partly it is because all these things are positive, negative number here. The whole system can be changed by switching the directions of the negatives to positive, positive to negative. Why do I say that? take a look at this one. Take a look at this one example I'm going to show you, okay? So there are many different packages that calculates, principal components. Listen everybody carefully, okay? This is what I used. I got negative values, right? You remember that? See, these are the things, minus 0.53582754, right?
Right.
So just hang in there, okay? This is one way. So next method, he is also giving you negative. Next method, okay? Next method, one moment. He is also giving negative. Are you with me so far?
Yes, sir.
Yes, sir.
He is giving positive, all of them. Did you understand? It's just a matter of switching the axis direction. Did you get it, Aruna? Why it's a little bit confusing? It is just a matter of switching, but it should be consistently explained. That consistency is important. Everybody gets it?
Okay.
The angle should be represented negative or positive, it doesn't matter, but it should be consistently explained. Okay? All right. Just stay put, everybody, stay put there. Let's go and finish this. So what do we, and also in this case, New Hampshire, what happens New Hampshire? Let's go back a little bit of interpretation here. New Hampshire refers to New Hampshire is small. Do you see this one?
Very, very small. Very small.
Very, very small, isn't it? And this is how it is coming together, okay? And then let's go back to Florida. This is very big. This is all assault also very big. But here, if you look at it, New Hampshire, assault is also small.
Yeah.
Makes sense now?
Right.
But these two axes, in fact, these two things seems to be capturing here in this line. Yes or no?
Yes, sir. On the line it there.
On the line, dead on the line, exactly. Which means I don't need the other axis.
Okay.
Okay, which means I don't need the other axis. Correct?
Yeah.
Excellent. Satya, Aruna. And we will do a little bit more explanation, huh? Very good. Excellent. Stay put with me. Stay there. Now let's consider this axis because mood situation you'll appreciate that. Arkansas is the extreme case on the line, dead on the line, right?
Right.
As well as New Jersey. Let's go to Arkansas, New Jersey. Arkansas, this. What is happening here? Can somebody note down this one? 8.8, 190, 150, 50 and 19.5. 8.8, 190, 50 and 19.5. I'm noting down all the four because the whole data is supposed to be represented by these two dimensions right now. And then the other one is New Jersey. Let's go to New Jersey. What does New Jersey say? New Jersey says 7.4, 159, 89, 18.8. Okay. So this is not cleanly coming out, right? Because I have taken out some of the dimensional variation by the first maximal explaining dimension. I have already removed that. If I remove that, what is remaining is explained by this. That's what it says, mathematics says. So I'm not getting that great clarity here as much as what I got here between Florida and New Hampshire. Everybody with me? I'm not just cheating here. I'm just explaining why I'm not getting a great clarity here. Because I would expect 8.8 and 7.4 both are same small, and then 190 and 159 almost in the same range. Maybe one is positive, one is negative. That's probably it. What is the average? If I take the average of assault, let's calculate the average of assault. I'm saying it is in between 190 and 159. Let's see whether that works out. I'm just exploring, articulating as we go along. Okay, mean of what? Mean of USARS. All four variables. Oh, it's not coming. Average. It should be average, I think. Average? No. What's going on? What is it? USARS. Okay, let me. God. Mean is fine. Now I want to do USARS one variable at a time. That's better, okay? One variable at a time. I want the 2, right? 2 is the one that
Assault.
Assault
type.
Good, that's cool. Really, I'm very happy. I didn't commit. I didn't commit in the wrong way. You see, this is 170. It is in between 159 and 190. Do you get it?
Right.
Isn't it what I said before I calculated? Honestly, I tell you, I did not calculate it ever in the class before. This is the beauty of my class. Every class is unique. Okay, and what I speak in the previous class in the same subject, I won't be speaking to you. That's exactly what has happened. I never checked this value before. That's exactly the reason why this is in this direction. Do you buy it?
Right.
Kind of.
Right.
You may not be buying it 100%, but I am taking it in the right direction.
Yeah, the PC1 axis probably has a weightage more towards murder no sollama sir. Appo PC2 is having weightage more towards assault.
No, it has both weights for both. Wait, let's go back. Let's go back to the weights. Here, right? So negative or positive doesn't matter, right? We are already bought into that one. So if you look at all these three things, it has weight for both. For all the things, it has weights, right? You know, compared to urban population. All these three things have a good weights compared to even PC2. For look at this smaller weight compared to, but it's the opposite direction. I understand. This is Aruna question. This is in the opposite direction. I understand. Okay, but less weight. Still less weight. Correct, Aruna?
Yes.
Excellent.
The significance clear புரியல. ஏன் இது ஒரு டைரக்ஷன் அது ஒரு டைரக்ஷன்.
புரியுதா?
இல்ல clear புரியல.
Okay. You know, see, because you have to think dimensionally, you know, adjusting, you know, keeping one dimension fixed and, you know, keeping another dimension varying, all those things, you know, you have to think through. It's a dimensional thinking, but I'm only using only two dimensions. That's all I'm trying to say. Okay, forget about PC3, PC4. I'm comparing here. I'm saying that there is a lot of weight for murder, a lot of weight for assault, a lot of weight for rape.
Right.
Okay, compared to in this dimension. But on the other hand, why is that PC2 is perpendicular in some sense? So not only lower dimension, but also you see this one. This is very high compared to this one.
Very correct.
Get it? This is not a perfect science. Remember that statistics is not a perfect. It's a kind of approximation, but dominating approximation is what matters. Always approximation, but dominating approximation everywhere. What dominates is what matters to us. That is the science of statistics. Okay, so that is why the PC2 lives on its own as a single dimension, separate, independent dimension. It is totally different angle. This is negative, this is positive. Absolute value, it is still less. So to tell you, Bala, it is weighing. Yes, it's weighing, you know, not bad, but it is opposite direction. First point, it is on the opposite direction. The second point, still less than this weight.
Agreed, sir.
Okay, so this is how is coming out in the graph here. You know, in the graph, that's how these are all coming. If you look at, you know, Virginia and Arkansas will be varying on this dimension PC1. You can predict this now where it's going, or not PC1. Sorry, PC2. Right? It is varying in this direction. Right? PC2. Delaware and Virginia are very close, but except for, you know, flip on the angle on the negative or positive direction. Most likely, it is on the assault.
And it will be closer to the mean. Somewhere close to 170 will be near Virginia.
Exactly. You are getting it.
Yeah. And the other one will be slightly lower. That is the difference between 170 and 180 probably, and 170 and probably 150 or 156.
Okay, good. Let's check how close we are. You know what is that? We are talking Virginia. But the problem is the point could be here or here. I don't know. That is where the issue is. You know, even though it's printed here or here, it doesn't mean the point is here in the middle. Are you with me?
Yes, sir.
So yes, sir. Here or here, I don't know. Okay, that's why there will be some difference. But nonetheless, Virginia and Delaware will be very, very close. Let's go. Virginia.
Yes, sir. Yeah. One will be slightly higher than, that is Virginia will be slightly higher than 170 on assault, and the other one will be slightly lesser than 170. That much I can definitely say.
Virginia is 156.
Exact answer, sir.
Deliver.
ஓகே மாத்திட்டேன்னு நினைக்கிறேன். இல்ல ஒரு நிமிஷம் சார் பார்க்கணும்.
Deliver is
இல்ல சார்
238. It's not slightly, but 238.
இல்ல சார் தப்பா சொல்லிட்டேன் சார். நான் தப்பா சொல்லியிருக்கேன். ஓகே
Yeah,
டெலவர் வர்ஜீனியா வந்து வேற மாதிரி இருக்கு சார். அது நெகட்டிவ் ஆக்சிஸ்ன்றதை மறந்துட்டேன் சார் அதுல.
Yes. No worries. No, don't apologize too much, okay? Because I'm happy you are getting there. I only want to make sure that others are also seeing the way you see it. You know, what you are seeing is not illusion.
Thank you.
Others should not think that way. I mean, why am I not seeing it? Don't that. Satya. Illa. You are good. You are able to reflect what he is saying. Amma, you have to spend time. I'm going to give you an exercise for you guys. Is that okay? I'm going to give you an exercise and ask you to plot it and interpret whether it makes sense. You shouldn't say that, well, it makes sense because mathematics did it for me. No. You have to interpret it out. This is see, that's why this data is popular, because it's just 4-dimensional. Mottame 4-dimensional. Data is 4-dimensional. Right? Data is only 4-dimensional. So you can kind of, you won't go more than 2 dimensions. No, typically, 50%. 2 dimensions.
சார் நியூ ஜெர்சில ரொம்ப ஜாஸ்தியா இருக்கும்ல சார் நம்பர். அப்போ இதுல இந்த கிராஃப்ல இருந்து பார்த்தோம்னா, இந்த கிராஃப்ல எனக்கு இப்ப தெரியல இந்த நம்பர்ஸ். நியூ ஜெர்சி will be forwards இல்லையா?
நியூ ஜெர்சி பார்க்கலாமே. நியூ ஜெர்சி is 159, 89, 18. Okay. இது வந்து small compared to, see, this direction murder is going to be small.
Okay, right.
The perpendicular direction murder is going to be small. That's what it means.
Yes, sir.
Right?
Urban population தான் ஜாஸ்தியா இருக்கும் இல்லையா? அந்த urban third dimension -0.87 அதுதான் ஜாஸ்தியா இருக்கும் PC2 ல அப்போ.
Yeah.
Okay sir.
So இது மீன் போட்டு பார்த்து தெரிஞ்சிரும்.
Sure sir.
Okay. மீன் தூண்டில் போட்டு பார்த்து மீன் போட்டு பார்த்து தெரிஞ்சிரும். Okay. So I want you to think about, for example, in the direction எடுத்து பாருங்களேன். So West Virginia, California எடுக்கலாமா?
That will be another interesting combination.
Yeah, West Virginia and California is another interesting stuff. Exactly.
Diagonally opposite, yeah. Okay, sir.
Yeah, diagonally opposite. You expect, more. Florida ennachu adhe pola dhaan nadakkanunga illaya. More. Say idilla. Sorry. With that, I'm going to stop the interpretations, okay? Because we are spending a lot of time. We need to move on. If it's all okay with you guys.
Yes, sir.
Florida, we say 15, right? It's not that much. It's the assault is too much, right? Florida's assault is too much. Well, this is also much. I remember. Sorry, this is murder, right? So 15 is not a small number. Both are big, right? And we said if that's the case, California, you should see, right? But you should see less of something because in the negative direction on the PC2 side. What is PC2 negative means what? I think it is. Let's see. It should be less than this. Let's see. Can you put a stake on the ground on that one? Well, it is already there. I saw this. 9 and 276. So does that make sense to you here? 9 and 276. This is 15 and 335. Everybody gets it? Does it make sense? Kind of, right?
Right.
That's what I expect at this time. Remember, you are seeing it for the first time. You got to think about it. Sir, is nariya vela sir. Apdidan thonde. Nariya vela sir.
So Nevada idla consider pannamnaka, it will be somewhere in between 9 and 15 for murder and somewhere between 276 and 335 for assault illaya?
Enga Nevada enga irukku?
Nevada.
Enga irukku Nevada?
Between California and Florida, sir. Left side la graph la.
Nevada la.
Two axis kaga solrேன்.
இந்த ஆக்சிஸ்ல குறைவா இருக்கும். இந்த ஆக்சிஸ்ல கொஞ்சம் அதிகமா இருக்கும். That's what it means.
Okay, sir.
What the PC2 means, okay? Okay.
Okay, sir.
I want to. There's some amount of spend. You have to spend your time in a focused way. Right now I'm talking. You have to listen to my words. You are seeing. You are also seeing the screen and so on. So, and Deepavali is getting closer and closer. I understand. You have to go through this. Are you with me, everybody? Thank you, Satyam. எங்க இருக்கீங்களா நீங்க? யாருக்கு சொல்றேன்? Durga and Abhi. Did you hear me? Did you hear me? Oh, it's time for them to go.
Yes, sir.
Oh, you're there. Okay.
Yes, sir.
Good. Did you hear all the talks that I had with Bala?
இல்ல sir.
புரிஞ்சுதுங்களா? Kind
Yes,
of.
sir.
ஒரு மாதிரி kind of தான் இருக்கும்.
கொஞ்சம் புரியுது sir.
Yeah, but you have to think about it. We will do one example. Maybe one assignment will do. I'll send you an assignment request. Okay, do that, interpret it, and that's the only way to train.
Okay, sir.
Okay. All right. With that, we will take a break now. When we come back, I'll do what else we have to do here. I think I have covered all the foundations of principal component analysis, which is going to be foundation for all the other things. Okay. Okay, 10 minutes. 10 minutes break. I'll be back.
Sure.
Thank you.
Thank you.
எப்படி பண்ணணும்னா இந்த டேட்டா வச்சு இது இன்டர்பிரட் பண்ணணும். இந்த டேட்டா வச்சு நம்ம பண்ணக்கூடாது. பிரின்சிபல் காம்பனன்ட் அதை வச்சு புரிஞ்சாதானே கரெக்ட். அப்புறம் இதே திருப்பி வச்சு பார்த்தா
ஓகே, ஒரிஜினல் டேட்டா வச்சு பார்த்துட்டு இருக்கோம்.
அப்ப கிடைச்ச இன்ஃபர்மேஷன் வச்சு என்ன பண்றோம்,
அதெல்லாம் கேல்குலேட் பண்ணி தான் இந்த இது கிடைச்சிருக்குது.
அதை வச்சு நமக்கு அது கிடைச்சிருக்குங்கிறது ஓகே.
One question might be coming to you. What is it? Let's take a look at this one. See, this graph, in this graph, how those 4 variables are related to these 2 dimensions. You know what I'm saying? How those 4 variables are, it's a different angle to it. Is everybody with me? How those 4 variables, original 4 variables are related to these kinds of PC1, PC2, right? We are saying the PC1 captures dominantly one direction, that is the murder. PC2 captures dominantly, I don't know, I think
urban population.
Urban
Population.
Yeah.
87% sir.
Yeah, urban, the urban population kind of, right? Some of them it catches the other, murder and so on, but overall we want to see how these are all correlated. These 2 are correlated to the original variable. Is that a good question?
Yes.
I think, you asked, but that's what I'm going to do. So if I can plot something like this, look at this one. These are correlations. How murder, assault, rape, and urban population are correlated to PC1, PC2. That's what we are trying to say. Is that right?
Okay.
So urban population direction is this. It's not really this. You understand?
Okay. Yeah.
The murder is not exactly this. It is very close in this direction, but it is this. Assault is closely related to this one, to the perpendicular line, the horizontal line. Are you with me?
Yes, sir. Yes,
so
sir.
how do I get this kind of information? That is what is called the correlations. Correlations are the correlations between the original data and the
transform dimension, new dimension.
Transform dimension, exactly, transform dimensions. So there is a function here in this case, this guy is writing the function trying to find out the correlation, and the correlation should be plotted in a circle only because it is always -1 to +1, right? It ranges between -1 to +1 correlations, both directions. So it is going to be a circular coefficient. So we have to do some little bit of transformation, and that's what is happening here, circular correlations, and that gives you an idea about, where the original weights are going in these 2 dimensions. Everybody gets it?
Yes, sir.
Okay. You can run this and you can get it. In order to do that, I need to go back to say, TT1. Yes, sir. PCA1. Okay, so I should be able to do this because it's using PCA1. Do you see this one? Everybody?
Yes, sir.
So I have PCA1. You remember this one? I have PCA1. All these things are based on PCA1. So I should be able to do that. Let's do it and then plot and then we will move on. So run this one. It's working. You see this one? Done. You get it?
Yes, sir. Oh.
So what is the benefit of this? Somebody can say that. I don't know. Can you say, Durga and Abhi, what is the benefit of this? We were kind of having difficulty to align whether totally this one refers to the urban population or this one refers to the murder. You remember murder and assault? But they are correlated approximately in this way. That's why we have some difficulties. We will never have, each axis will not be exactly one variable, right? We know that much. But because of their intercorrelations, PC2 is mostly represented by these 3 variables, and PC1 is represented by urban population. That's what
இல்ல சார் மாத்தி சொல்றீங்கன்னு நினைக்கிறேன் சார். PC2 வந்து urban இல்லையா?
PC2 is urban population, the other one. Yes, exactly. அது புரியுதுங்களா? Are you able to hear?
explain பண்ண முடியுமா சார் circle of correlation?
நீங்க வரதுக்கு முன்னாடி சொல்லிட்டேன் ஆரம்பிச்சிட்டேன் நினைக்கிறேன். Sorry about that. Okay, so here what I'm saying is when we were explaining the other graph, what graph? This one moment. This graph, when we were explaining this graph, we were kind of having difficulty, and we say this is totally about one dimension, that is about murder and assault, right? If you remember, and whether this completely explains the urban population. You remember that? We were kind of it's approximately. So what is that approximately? Can I say more? So what I mean is I have to find out the correlation of the original variables with this PC1, PC2. And by getting the correlation of that, I'll be able to explain that struggle. Are you with me? So one more way of explaining the difficulty of capturing the 4-dimension data in 2-dimension. Get it? So that is what this graph is all about. That's what this graph is all about. And how do we get it? I went through a calculation method. Basically, I calculate. It's a function defined in this link. I think I have it in my PowerPoint deck. This link. So basically, I ran this. I got this output. Because it already uses PCA1. PRCOM based calculations. So it has all the PCA1 values and I could use it. So that's good?
Yes, sir. Your chinna question, sir, in that one and data probably understanding murder, assault, rape, crime, urban population is not a crime. This in that mix.
Fantastic. That is probably another way of interpreting why all these crimes are in one direction. Urban population is in another independent dimension because crimes are correlated highly together. That's what it means.
Okay.
Make sense?
Okay. Right.
That was an excellent observation you made. I don't know whether others understand your question. All the crimes are correlated. Do you agree with me? Murder will be correlated with assault. Assault will be correlated with rape. Rape will be correlated with murder. More so. I didn't say that, usually urban population, more urban, more crime solo, right? Another in the angle on the it's not perfect. Does it make sense? To me, it looks like it makes sense, but does it make sense to you? The interpretability.
Yes, sir. Yes, sir. புரியுது சார். So crime எல்லாம் ஒரு பக்கம், but எங்க நடக்குது அப்படின்ற மாதிரி அந்த கான்சென்ட்ரேஷனை தனி ஒரு ஆக்சஸ் பக்கத்துல இருக்கு. பட் அதுக்குள்ள ரூரல் காம்பினேஷனும் கொஞ்சம் இருக்கிறதுனால exactly it is not on that line, கொஞ்சம் tilted-ஆ இருக்கு.
There is mixed issues, right? So there are areas where they invest more money. Here is another observation. There are some cities they invest more money to control crime. They have less relative to the population.
Agreed.
So that's why it is not exactly urban population. For example, another reason.
Right.
So with that, we move on. Correcting my Satya.
Okay.
Very good.
But interpret.
Well, don't worry about that because you remember I told you this could be this way also. This could be that side. It's just a matter of the negatives, positives, moved in the data creation, the output creation. I showed you there are 4 methods which used all negative values for the PC1, but then the 5th one had all positive values. I switched all the values actually, for all the directions. You remember that one? So it's just it's a kind of, it's not real, it's illusion. It is. This could have come this side also, yes, and this will be here, somewhere here.
Sir, but we use the same data. The previous graph it shows some values in what is it?
என்ன சொல்றீங்க? இது ஒரு நிமிஷம். இது இல்ல.
Data same.
Same data தான் நம்ம பண்ணிட்டு இருக்கோம். ஒரு நிமிஷம். Are you talking about this?
இதுதான், but data.
Yeah. Data is same. Same data.
Okay, but same data, but we இந்த சைட்ல இந்த பாத்தீங்கன்னா பாசிட்டிவ் சைட்ஸ் நமக்கு வேல்யூஸ் தான் வந்திருக்கு. ஸோ இதுலயும் சேம் தானே யூஸ் பண்றோம், சேம் டேட்டா தான் யூஸ் பண்றோம். ஏன் நமக்கு அவங்க எதுவுமே காட்டல பாசிட்டிவ் சைட்ஸ்ல இந்த கார்லேஷன் சைட்ல கார்லேஷன்.
Yeah, this is how the translations are done. Okay, how the translations are done. So, for example, I'll mathematically explain that to you. See, and the way I explained it is, I showed you 5 different ways of calculating Pca for principal components, functions available in R, and one of them switch the signs. Okay, I showed you that also. Do you recall that one? Okay. What I'm saying is, the way how you subtract the data, how you do that standardization, all these things, man. I only can say that it is x bar minus x. Why you might ask why they might do that way, but the point is, it doesn't change it does not change the interpretation because yeah. So what I'm saying is I showed you 5 different ways of calculating PCS, right? And of course, I walked you through that particular page. In that one of the packages turns out the values to be completely different, opposite. Okay? And I'm saying it is something to do with the way you translate the data. Okay? And but what will happen is, if I used his answers, all these things will be again coming to the same side, because he switched the data, but then accordingly all the other things will also switch. So what the net, the relationship is not going to change. It's only an axis how it is defined. My x1 வந்து minus x1 போடுறதுனால என்ன ஆகும், it will shift அவ்வளவுதான். x1 x2 ரெண்டு axis வச்சுப்போம், xy வச்சுப்போம் ரெண்டு axis. You do the work all of them as xy, I do the work as minus xy. What will happen? It will only flip the data. All the resulting data will be flipped from this side to this side. I understand that part. Why the heck people are doing it in different ways? Just do it one way. I didn't throw it, right? But the thing is, I don't know. People have different ways of approaching it. For example, I'll tell you. During World War II, this is a very interesting example I'm going to tell you. World War II, when all these real analysis were developed, okay, during the time before and so on. Russia and America have, they are at loggerheads. Okay, one whatever does, the other one will do the opposite of it. Okay, as long as the truth is, each feel that way, right? As long as the truth can be explained, it doesn't matter to me. But because of my animosity, Russian animosity towards America, American animosity towards Russia, whatever America does culturally, I mean mathematically, I'm going to come to that mathematically. The whole probability theory was defined using what is meant by right continuous functions by Americans. And the Russians will do it with using what is called the left continuous functions. Culture, people just use it, but consistently they'll get the same result. And that's how they define the whole scientific process. So likewise, you may use x and y, I'm using minus x and y. For some consistent thought process I have been developing, I might use it that way. But as long as all the results are consistent, it's okay. That part you buy it, right? Consistently explained. It comes down to explanation. So நீங்க அப்படி போட்டா என்ன ஆகும், அவன் போட்ட இந்த ஒரு நாலு பேர் கரெக்டா அதே ஒரு மாதிரி தான் போட்டான், ஒருத்தன் மட்டும் வேற மாதிரி போட்டனால அவனோட ரிசல்ட் will be என்ன இருக்கும், Florida will be this side, right? And the New Hampshire will be this side. But he switched the axis. And accordingly, all the other calculation will change in terms of the signs. So probably a good exercise is now to actually follow his results and plot it and convince ourselves one way. Okay? I don't know. I talked to you convincingly.
ஓகே, அதுல வந்துட்டு வேரியேஷன்
சார் இந்த பிளாட்ல PC2 கிட்ட தான் கார்லேஷன் அதிகமா இருக்குன்னு சொல்றோமா, அந்த மாதிரியா?
No, this refers to, this is horizontal axis, this is the vertical axis, right? So in the horizontal axis, in the horizontal PC1, the horizontal axis represented by PC1. The PC1 captures the variations, and these are all highly correlated. That's all it says. These are all highly correlated because that's why they're all together, in bunched together here. And that makes sense, because when there is a rape happens, the person is more likely to be murdered. You know, likewise, when there is an assault happens, you know, it could be, you know, it could lead to murder unless you just yield and say nothing, give away everything. You know, the person might kill the other person. So that's why these are all, you know, clumped together. But here is the situation. The question is, now, why is that urban population is very different compared to this one? Because that is defining this axis basically.
Right.
And well, my point is that no, the urban population is not 100% correlated with this one. At least majority correlation is not by this population size. These things happen because the bad people are located irrespective of, you know, not totally, I cannot say irrespective, because, you know, it is, the urban population is totally independent. You know, it's an independent, almost independent dimension, right? Almost, because it's going this way, right? It's not this, you know, if it is going this way, then I cannot say that. Almost, right? So the point is, no, that's because there are a lot of urban centers which, you know, manage their crime activities differently. என்ன சார் இது ரொம்ப ஒரே கூஷி கீஷியா இருக்குன்னு தோணும்.
அதே நேரத்துல இதுல இன்னொரு क्वेश्चन சார், அந்த அர்பன் பாப்புலேஷன் லெஃப்ட் சைடுல டில்ட் ஆயிருக்கு.
It is statistics, is the dominant factors is what matters. Okay, go.
ரைட் சார். சார் ஒரு சின்ன क्वेश्चन தான் இந்த இடத்துல. அர்பன் பாப்புலேஷன் இப்போ லெஃப்ட் சைடுல கிளாக்ல பாத்தீங்கன்னா 700 அந்த டைமுக்கு ஈக்குவலண்டா இருக்கு. இப்போ 5க்கு மாறிச்சு அப்படின்னாக்கா we will give the almost the same explanation இல்லையா? பெரிய டிஃபரன்ஸ் இருக்காது நம்ம இன்டர்பிரேஷன்ல இல்ல. இப்போ லெஃப்ட் சைடுல வந்து 7 இருக்கிறதுக்கு பதிலா ரைட் சைடுல இந்த பக்கம் டில்ட் ஆயிருந்தா அதே ஆங்கிளுக்கு are still our arguments on urban population will still hold good.
You mean here or here?
Yes sir. லெஃப்ட் சைடுல இருக்கிறது ரைட் சைடுல வந்ததுன்னு வைங்களேன் டில்ட். அதே ஆங்கிளுக்கு அதே டிஃபரன்ஸ். Exactly.
That is fine. Yeah, that is fine. But what it means is it's going away, you know, from the clusters of this, right? It's
correct.
More uncorrelated. It's kind of, it's correlated. Somewhat it's correlated. It's not totally correlated. If it goes here, that is totally uncorrelated, right? I mean, if it goes here, I mean, in this direction. I'm thinking this direction. Yeah. If it is here, I think it is totally uncorrelated.
Okay.
In this range, somewhere in this range.
Okay. Fine.
They are moving the same direction. That's what this means. That is, no, these are all positively correlated. That's what it means.
Right.
Correlated means whenever this increases, whenever this urban population increases, in general, there is some correlation contributing to this. If it is here,
this statement actually, yes sir, when urban population increases, the chances of rape or murder or assault, the probability is increasing. That is what is being explained. If it falls exactly on the y-axis, probably it is independent because it is perpendicular.
Right, but it is not. That means there is almost no correlation.
No correlation, zero correlation on the ramp. Okay.
Yeah, okay. Almost, yes.
Almost. Okay, sir. Thank you.
No, it's you always have to protect yourself with almost, you know, significantly, not significantly, all other things remaining the same. This is a reality, and you know, it's a science. You know,
right.
You know, I just want to tell you that it's a science still.
Right. So, upper right la vandirunchina, I would have said it is negatively correlated, which means if there is an urban population increase, assault, murder, rape alla koranjiruchindra mari solla vendirukom appo, which is not the case in this data.
Right,
Okay.
you mean in this direction only, right?
Yes, sir. Yes, yes. Okay, sir.
I would say more and more in this direction, yes.
Right, sir. Okay, okay, got it. Thank you.
No, wait a minute. No. What did he say? In this direction or here? No, hold on. In this direction, here or here? Think about it. This is positive correlation, right? These are all zero. They're almost zero. Negative, some negative is there, some positive is there. So here, if it is not, it is almost independent. Perpendicular. It's almost independent. Okay.
Right.
Kind of.
Right.
More perpendicular. But what we are saying here is that if it is here in this direction, then it's the opposite direction moving.
Okay, okay, right. That makes sense. Okay, sir, I will buy that. Yes. Okay. Opposite are not totally okay. Increase in urban population will have a decrease in murder, rape, assault, and Ramari Varam.
Yes,
okay,
yes.
Got it, sir.
But you see a lot of very different kind of saying it in English, right? So many things are happening here, but you pick up the most important things.
Sure, sir.
Is it frustrating, guys? Satya? Thanks.
No.
Thanks. Sir, Kedar, are you there? Okay, what about our fan of Abhi?
இருக்கும் சார்.
Huh?
இருக்கும் சார்.
Okay, I will finish it soon, but how about this? Maybe we should start the factor analysis next time when you come back, because I think I know anxieties are there building up, and Kedar already left. What do you think? I want to hear from you guys, from you folks. What do you think? Huh?
Postpone பண்ணிக்கலாம் factor analysis.
Postpone பண்ணிக்கலாமா இருந்தா? What do you think?
எனக்கு ஒரு ப்ராப்ளமும் இல்லை சார்.
இல்லையா? சரி. என்ன சொல்றீங்க?
லாஸ்ட் பார்ட் அதுக்கப்புறம் பார்க்கவே
லாஸ்ட் பார்ட்
லாஜிஸ்டிக் ரெக்ரெஷன் நம்ம பேசினோம்ல, அதுக்கப்புறம் இந்த ஃபைனல் அனாலிசிஸ் பார்ட் வந்து எங்க சைடு அது கவர் பண்ணவே இல்லை.
எனக்கு அருணாக்கு பிரசாந்த்க்கு 3 வருஷம்.
என்ன ஸ்டார்ட் பண்ணல?
லாஜிஸ்டிக் ரெக்ரெஷன் நம்ம இங்க பேசினால நீங்க அந்த ஃபைனல் அனாலிசிஸ் பார்ட் அதுக்கப்புறம் நம்ம டிஸ்கஸ் பண்ணவே இல்லை. ஏன்னா அதுக்கப்புறம் டைரக்டா நேத்தி கிளாஸ்ல இது ஆரம்பிச்சிட்டோம். நம்ம
என்ன பண்ணணும் அதுல ஞாபகம் சொல்லுங்க. என்ன பண்ணணும்? நான் ஏதாவது சொன்னேன்னா லெட்ஸ் டூ திஸ் அப்படின்னு சொன்னேன்னா நம்ம பண்ண ஒரு அனாலிசிஸ் இவர் பண்ணறா அது what is it called the
மண்டே பண்ணினாரு. மண்டே எங்களால அட்டெண்ட் பண்ண முடியாது சொன்னாங்க. அந்த கிளாஸ் எங்களுக்கு வீக்கெண்ட் கிளாஸஸ் மட்டும் தாங்க.
So I will record this and then post it to you. Is that okay? Because those guys benefited by coming weekdays. Can I record it and post it? I think that is better. Logistic regression practice session.
Yes, sir.
Okay, cool. Very cool. How about sisters? Abhi and Drisha. How is it going? Ready?
ஓகே சார், ஒரு தடவை வந்து லீனியர் அண்ட் லாஜிஸ்டிக் சொல்லி கொடுத்துருக்காங்க சார். அது ரெக்கார்ட் பண்ணி நீங்க ஒரு தடவை சென்ட் பண்ணுங்க சார். நாங்க மறுபடியும் வந்து ட்ரை பண்றோம்.
பேக் பண்ணிட்டீங்களா? நான் போறது வந்து இட் இஸ் யூஸ்ஃபுல் ஃபார் எவரிபடி. ஓகே, ரெக்கார்ட் பண்ணி போடலாம். But I got to spend time, on other things. Okay. So are you ready? Can you stay? I mean, how is it looking like? What I was suggesting, I think somewhat the spirit is, I don't know, I felt that way. We can start factor analysis next class, and in the meantime, I will record one logistic regression, one problem. Is that okay? One problem. Oh, you are not seeing me. In the meantime, I'll record one problem, one logistic equation. Will it help? Record பண்ணி போட்டா கேட்பீங்க இல்லையா?
Sure, sir.
All right, sounds good. I want to let you go early today. That's fine. We didn't do much, but that's coming up. We kind of, I hope we kind of seen the PC. Is there a good understanding?
Adula voice break ஆயிடுச்சு sir, sorry.
அதே பின்னாடி நாய்ஸ் எல்லாம் இருக்கனால இது வந்து it's going to be wrong. I said sorry. I kind of completed PCA. Everybody buys it.
Yes.
Satisfied. You can feel confident. You can work with that. Your company problem.
Yes.
Getting there. Fine. You have to work also on your side. You remember, every hour I spend, at least 1 hour you have to spend. Usually you have to spend 2 hours.
Yes.
Okay?
Agree.
So take good care. Enjoy your Deepavali. Be safe. I look forward to seeing you. Happy Deepavali, everyone.
Wish you happy Diwali, sir.
Thank you.
Wish you happy Diwali, sir. Happy Diwali.
Happy Diwali, sir.
Happy Diwali to everyone.
Bye. நான் சொல்றேன்னா சொல்லி பின்னாடி வெடிச்சுட்டே இருக்குது. நான் ஒண்ணும் பண்ண முடியாது. கேக்கலையா? ஐஓஏ கேட்காது. ஏன்னா அவங்க பின்னாடி தான் நிறைய வெடி எல்லாம் வெடிக்கிறதா நினைக்கிறேன். அவங்க அந்த பக்கம். You guys are facing a lot of noise outside.
Yes, sir. Yes, sir.
No. Have fun. Bye bye.
Thank you, sir. Thank you, sir. Bye, sir.
Okay. I will write for you. I know there is a lot of noise behind the building or by the side. Okay.
Display varla, sir. Display varla.
Are you reading my chat? Okay, I know there's a lot of noise behind the building. You can't concentrate. Have fun celebrating Deepavali, okay? Bye.
Bye, bye, sir.
Angelia, maybe even பக்கத்துல. What is his name? Either one of them, Bala or sisters.
எங்க கிட்ட இல்ல சார், என் இடத்துல இல்ல சார். இப்ப ரைட் நவ இட்ஸ் குவைட்.
sisters பக்கத்துல நினைக்கிறேன்.
எங்க ஏரியா பின்னாடி இப்பதான் சார் ஸ்டார்ட் பண்ணிருக்காங்க.
ஓச்சி ஏதோ
ஸ்டார்ட் பண்ணிருக்காங்க.
ஏதோ இட் இஸ் நீங்க தான் வெடிச்சிட்டீங்களா தெரியாது. Have fun. Thank you very much. No concern. We will do more when we come back.
Sure,
Be safe.
Sure, sir.
Enjoy the session.
Thank you.
Enjoy the Deepavali. Bye bye.
Happy Diwali. Thank you. Bye bye.
Bye, bye, sir. Thank you, sir.
Bye.